everybody, welcome back. We're going to be doing Lab 2 today, which is called Impact Test on Metallic Materials and the Ductile to Brittle Transition Temperature. The purpose of today's lab is to investigate the fracture behavior of different materials. To do this, we are going to use the Sharpie Impact Test to compare the fracture toughness of a BCC steel and an FCC alloy. And we will also look at the difference in fracture appearance and impact toughness of ductile and brittle materials. So the Sharpie Impact Tester is the machine right behind me. You can see the whole thing from top to bottom, and I'll explain a little bit more. So this is the Sharpie Impact Tester. What it is we have a weighted pendulum that is mounted up top, and when we release it, it swings down and hits a sample which is placed at the base here. So if I have an imaginary sample, I can open the door, put it in, close the door, and then I can release the pendulum and you can see it swings. In the center of the machine, we have a dial that measures the impact toughness of our material in joules. So when there is no sample placed and the pendulum swings all the way through, the dial actually reads 0 joules, which makes perfect sense. I can bring the dial back to its initial position and repeat the process for an actual sample. Today we are going to be using a BCC steel. So you can see the sample right here, and if you look very closely, you can see that there is a line etched into the sample. So this is placed on Sharpie samples intentionally because we want the sample to fracture in a certain position. So this ensures that crack initiation and propagation will occur from the defect that we've placed in our sample. And it creates consistency across our samples during testing. There's also a diagram of the piece and how this etch is cut into it in the lab instructions. If you look at the Lab 2 instructions, you'll also see that we have impact toughness data across a variety of temperatures recorded already for a copper sample, brass samples, and then we have almost all of the data for our 1018 steel. We're just going to finish the last 3 tests today to fill out that table so that you can plot impact toughness and temperature and find the ductile to brittle transition temperature of each material. So I showed you what the samples look like already, but we are testing the samples at different temperatures. So we have our first sample that is just sitting here at room temperature. We have a second sample that you can see is stored inside a block of dry ice. So this is going to be our minus 70 degree sample. And we have a third sample and we have a third sample over here that's hanging out in a pot of boiling water. And this is going to be our 100 degree Celsius sample. So I will start off with the room temperature sample. I'm going to tape my sample and I'm going to place it in these tongs, and you can see that the tongs are actually designed specifically to hold Sharpie samples. So they have that little notch out And that's exactly where they're going to grab our sample to hold it firmly. And we're going to use the tongs to place our room temperature sample in the machine with the notch facing away from the pendulum. So I've faced my notch this way. I'm going to close the door. The machine is zeroed, and now I can simply run the test and read off the impact toughness. So the test is complete now. Looking at the dial, I can see an impact toughness of 140 joules, and I can retrieve my sample so that we can look at the fracture surface. One thing I'll tell you right off the top is that my sample was room temperature going in, and now it's quite warm. So it's absorbed a lot of energy, and there's been a temperature change in the material. If we look closely, we can see that we have what appears to be a pretty ductile fracture here. So you can see that the sample is still intact. I'm going to grab the dry ice sample. So I've got my dry ice sample in the tongs. I'm going to place it in the machine just like before. With the notch facing out, I'm going to zero the machine again. And I can run my test. So these results are quite different than our boiling water sample. We can see already that the dial swung all the way back to around 3 joules. If I go retrieve my sample, oh, that's cold. I can see, so I have my room temperature here and I have my dry ice sample. You can see we've got brittle fracture going here. We've got a nice clean fracture surface. It's a straight line across the sample as opposed to the more ductile fracture that we saw on our room temperature and our boiling water samples. So the last sample we're going to do is the boiling water sample at 100 degrees Celsius. So I'm going to go pick that up with the tongs. And I'll place it in the machine. And I want to run the machine as quickly as I can here, just so that I don't lose too much heat from my sample. So I can retrieve my sample again. And I see that I have an impact energy of around 145 joules. And we can compare again. between our room temperature and our over here and our boiling water sample in the tongs over here. We have pretty similar ductile fracture characteristics. It's hard to show these. And we have our brittle fracture over here at our minus 70 degree sample. So keeping all this in mind, we know that our ductile to brittle transition temperature for our steel samples must be somewhere between 23 degrees and minus 70. And by plotting our impact energy and temperature, we'll be able to find exactly where it is for the steel and also for our brass and copper samples. Beyond this, we saw some of the characteristics of a ductile fracture versus a brittle fracture. And we've covered a little bit of how the Sharpie impact test works. I'll be following this lab up with an email again, reminding you of some of the important things to include in your lab report, and a Word document with the data points recorded in it. If you have any questions, don't hesitate to email me or get in touch, and I'm happy to help out however I can. Thank you for watching, and thanks a lot for your time.